Math 3, Unit 2, Section 6. Today we're going to talk about solutions of functions. And actually, we've already been working through solutions of functions. Yesterday, or the last time you were here, we had we had our straight line and then we had a graph, right? And we found the 2 points that they intersected. Do you guys remember that? Okay, so today's kind of the same idea, except for sometimes we have a graph that has different things on it, okay? And so right here, and everything that I write down, I think you should write down so that when you're doing your homework, you can go back and look at it and understand what you've done, not just see an answer. But this says, list all of the labeled points that are a solution for f of x equals 0. Now, what's another way of writing f of x equals 0? Okay, good. So I'm going to write down y equals 0. And what y equals 0 is, that is actually your x-intercept. Because it's going to the point where y is 0. So it has to be a point on the x-axis because y is at 0. Okay, and so where are the x-intercepts on this graph? A and E. So the answer for A is A and E. Okay, another thing that you can kind of put here is the question is basically asking you, when does y equal 0? Okay, and y equals 0 here at A and E. If you were to write these as ordered pairs, this is A comma 0 and this is E comma 0. So that is when y is 0. Everything else in the graph would actually have a value for y. Oh, those are parentheses. So whenever you're stating ordered pairs, they're always going to be parentheses, not brackets. Brackets is usually just when we're talking about like our domain or range or the solutions on a graph. Okay? All right, so the next one says, list all of the labeled points that are solutions for y equals f of x. Well, what that is talking about is talking about the entire graph. This right here, and I should have labeled this. Oh, it says y equals f of x here. We can put an f of x on here. But they're basically just saying, what are all the solutions for y equals f of x? So we're going to write here, to remind ourselves, solutions, I don't know, on the graph. We'll write it like that. So what are all the points on the graph here? Good. A, B, C, D, and E. All of those are solutions for y equals f of x. Okay, so the next one says, list all the labeled points that are solutions for x equals 0. So x equals 0 is actually what? Very good. That is actually your y-intercept. Okay, and so what is the only point on here that's a y-intercept? D. And this point right here is actually 0 for the x and then D for the y. And so that is where x equals 0. You can see that for that ordered pair, x is 0, y is D. Okay, questions? Yes? Sure. Okay. Yes? This is the only point that has 0 for a y, or 0 for an x. Why wouldn't I write this as an ordered pair?
No, D.
Right here?
Yeah.
On here on the graph, I'm just kind of visually showing you that the ordered pair would be 0 for the x and D for the y.
If they were numbers, can we just write a number?
Yeah. So how this is working today is they are going to give you, for your homework too, and there'll be a test question too, where they are just going to put letters on the graph. If there were numbers there, then yes, you would write the number answer as well. In this case though, like I don't really know where the C ordered pair is. I know they're just giving this point to C. Okay? This one though, I know specifically that the y or the x is 0. and then I just gave the y d because it's at that point d. Okay, but yeah, these answers you're just going to give the letter answer, not an ordered pair. I was just trying to make you understand that where the x's are zeros and where the y's are 0. Okay, so are you guys ready to try the next example? Okay, on the next example, you'll notice that there are 2 different graphs. There's y equals f of x and y equals g of x. They did not label these for you, though, to know which one is which. So we are going to label them. This straight line right here, that will be your g of x value. And they should also have arrows at each end. And so your quadratic here is f of x. Okay, so A, I'm going to give you just about 10 seconds, 15 seconds to look at that. But based on what we learned in the first example, see if you can figure out what are the points for f of x equals 0. And what you need to be careful of is that you are only looking at your f of x graph. And what I sometimes do on these too is that I will just highlight one of the graphs so that I can see kind of the difference between the two, and it makes it easier to look at. So I just decided to highlight f of x, and then the g of x is not. Yes. Normally they will actually be labeled. So there was no way for you to know except for I told you. It just wasn't in the notes for some reason. Okay. Yes. Do you see that in any of the questions? What? It would just mean, yeah, if they put a 0 here, that would mean like, tell us the answer for when x is 0. What is the answer for y when x is 0? All right, so who thinks they have the right answers? Okay, so anybody want to share what they got? Good, okay, A and D is correct. So remember, f of x equals 0 is where y equals 0, which means that it's your x-intercept. And so on the f of x line, the x-intercepts are at A and D. How come I didn't choose H or G? Very good, it's not on the f of x graph. So you have to make sure that you're only looking at your f of x graph. Okay, B. It says list all the labeled points that are solutions for g of x equals f of x. What do you think they're talking about there? Very good. And so we're going to just say when the graphs intersect. Okay, so that's where they equal each other, is where the graphs intersect. So do we see any points where the two graphs intersect? Very good. B and E are correct. So you can see right here, g of x and f of x cross. And then same thing right here, g of x and f of x cross. And if you wanted to, you could highlight the other one in a different color if you wanted it to stand out more. Okay, C. List all of the labeled points that are solutions for x equals 0 on the graph of f of x. So what points where x equals 0? I'm going to go ahead and okay, so what do you guys think the answer is? C is correct. So again, x equals 0 means that it's a y-intercept. Okay? And so you can see right here that on the f of x equation, C is the only point that is where x equals 0 or is a y-intercept. Okay, any questions? All right. D, it says list all of the labeled points that are a solution for y equals f of x. So what does that mean? Good. All of the points on what? Very good. On specifically f of x. So what are all the points on f of x? Good. A, B, C, D, and E. Okay, and then the last one, the last question here, it says list all the labeled points that are solutions for y equals g of x. And so that's all of the points on g of x. And so that answer is what? B, F, H, E. Okay, because as you can see, G is just a point. It's not on either one of the graphs, correct? They just threw that in there. Okay, any questions? All right, again, please make sure you're not on your cell phones. Okay, this next part is a little different. You can see that there is this table. Okay, and it tells you f of x values. So what they're saying for f of x, when x is 0, the answer, or y, is -2. When x is 1, on the f of x graph, y is 0. Okay, and we could plot all these points over here on this graph. If you want to do that, you can, and you'd like connect the dots. Okay, and so you'd have 3 different lines that are connected by dots, but it ends up being this very tiny, small picture, and it's really hard to see what's going on. And so I'm going to teach you what I think is the easiest way for doing this. Okay, so are you guys ready? We're going to start with A. It says, on the number line below, shade the intervals between the integers where the solutions to f of x equals g of x. Based on what we just learned, f of x equals g of x means what? Where they intersect. Very good. So this right here means where they intersect. Okay, so it says where f of x equals g of x must exist. If it is not necessary that the solution exists, explain why. Okay, so what we're going to do is we're going to kind of plot these points. We're going to think of this line as being like our x-axis, and our x-axis is really y equals 0. Okay, so it's like this is kind of our line here, y equals 0. And so we're gonna just kind of plot points based on where f of x and g of x are. So at 0, f of x is at -2. And so what I'm going to do is put a little like point down here. I'm just kind of making up where I think the -2 would be. And I'm going to write an F here so I know that I'm talking about F. And then at 0, G is at 4. And so I'm going to put that above the line. Okay? Because this is kind of like my 0 line. Anything below is going to be a negative value. Anything above here, I'm going to put a point here. This is G. So right now, my g of x equation is above my f of x equation. Is everybody okay with that? Okay, so now we're going to go to 1. So at 1, f of x is where? 0. And so I'm going to put a point here at the 0 line, and I'm going to label that as f. And then g is at 1. So I'm going to put a point above the line, and that's at g. And we're going to connect these. So right now, the F and the F connect, and the G connect. And have they intersected yet? No. Okay, so now we go to 2. And F is at -1. So I'm going to put a point below the line, and I'm going to call that F. And then G is at -2. Is that below or above -1? It's below -1. And so my G is going to go underneath the F because it's smaller. Okay, and so again, I'm going to connect my F points, and I'm going to connect my G points. And what do you notice there? Very good. In fact, I'm going to draw an arrow right here, and I'm going to say intersect so that you can see. So that means, because it had said to like shade the intervals, I like to just highlight. So from 1 to 2, there is an intersection. So there's going to be a solution to where f of x equals g of x somewhere between the values of 1 and 2 because they're intersecting. Okay? So now we're going to go to 3. So f at 3 is at what? -4. So I'm going to put like a point down here and call it F. And g of x is at -6. Is that below or above the F? Below. Okay, and I connect those. And did those intersect? No, no intersection there. And then we go to 4, and F is at -2. So I'm going to put an F for -2. And g of x is at 1. So that's going to go up above, and that's g. And so we connect our g's together. We connect the f's together. And did those intersect? Yes, so that means that there also has to be a solution to this equation between 3 and 4. And that's it. That's your answer. Do you guys have questions? Okay, so we're going to do another one. So now we're going to do f of x and h of x. So this time I'm going to make points for f and points for h. Okay, so at 0, we have f is at -2 and h is at -1. So which one's going to be lower? -2. The -2, good. And so I'm going to put a point here for h, and then below it I'm going to put a point for f, because -2 is underneath -1. Okay, then we go to 1, and f is at 0, so I'm going to put a point there for f at 0, and h is at 3, which will be above the line. Okay, good. So I'm going to put a point up there for h, and we can go ahead and connect those before we go to the next set of numbers. So at 2, f is at -1, so make a point below for f, and h is at 1, which is above the line. Connect those. Okay, at 3, f is where? -4, so that's below. Mark that as f, and then h is at -2, which is also below the line, but is it going to be above or below f? Above, good. So again, connect. Have we seen any intersections yet? Nope. Okay, and then we get to 4, and at 4, f is at -2, so that's below the line. We have an f, and then h is at -1. Is that our above or below the f? Above. And so that's my h. We connect those. Did they ever intersect? No. So this one, the answer is no solution. And why is that? Why is it no solution? Very good. The graphs never intersect. Questions? Okay, we're going to the next one. Okay, so on the number line below, shade the intervals between the integers where g of x equals h of x. Okay, so you guys are going to have to help me out because I can't have everything on the screen. So you're going to have to look at your papers. Okay, and so at 0, what does g equal? 4, so that's above. We'll make a point, call it g, and then h is what? Okay, and so that is below the line. We have h. At 1, what does h equal? Or sorry, what does g equal? 1, and then h is 3. So what's going to go on top? Good, so I'm going to put h here and then g below it. So the main idea is knowing which one is above and which one's below. But what do we notice happens there? There is an intersection. So we're going to highlight from 0 to 1. So there has to be a point that those intersect between 0 and 1. Bless you. Going to 2. Okay, what is my value for g? -2, and then h is 1. So g is below the line, and h is above the line. Okay, and we connect those, and did they intersect? No. At 3, g is at what? -6, and h is at, so which one is h above or below g? Above. Good. So we mark h, connect those lines. Okay, at 4, g is what? 1, and h is, so g is above the line, and h is below the line. And we connect those, and do they intersect? Yes, so we're going to highlight there. All right, any questions?
Would it be okay if you like just plotted G all at once and then you did H?
Yeah. Yeah, just as long as you know where it goes, if it's going above or below them. Yes. Okay, now D is slightly different. It wants to know, on the number line below, shade the intervals between the integers where the solutions to f of x equals 3 exist and g of x equals negative 3 exist. Okay, so we're going to kind of plot this one differently. And I'm going to put f of x on the top of the graph. And I'm going to put g of x on the bottom of the graph. And I want us just to, like, at 0, what does f of x equal? We're just going to write the number for a minute. So negative 2, and then at 1 it's at 0. At 2 it's at negative 1. At 3 it's at negative 4. And at 4 it's at negative 2. And then we're going to do the same thing for g of x. So at 0, g of x is at 4. And then at 1 it's at 1. At 2 it's at negative 2. At 3 it's at negative 6. And 4 it's at 1. And I got all that information from my table here at the top, right here. Okay? So what we're going to do now is I'm just going to say yes and no. Is there a negative 3 between negative 2 and 0? No. Okay? There is no negative 3. So if you're looking at a number line and you're at negative 2 and you go to 0, there is not a negative 3 in there. Okay? From 0 to negative 1, is there a negative 3? No. From negative 1 to negative 4, is there a negative 3? Yes. Okay, so I'm going to put yes here. And from negative 4 to negative 2, is there a negative 3? Yes. Okay. Now, so we know there's 2 places where f of x equals negative 3. In order for it to work for both, the same has to be true on the g of x. So honestly, these two don't matter because we already know the answer is no. But we could still go through and put no, no, yes, and all that stuff there too. But so we're going to go and do it on all of them, but this wouldn't matter if this is a yes because it has to be yes for both. Okay? So from 4 to 1, is there a negative 3? No. From 1 to negative 2, is there a negative 3? No. From negative 2 to negative 6, is there a negative 3? Yes. And from negative 6 to 1, is there a negative 3? Yes. And so it happens that these both had them at the same points. Sometimes it works that way, sometimes it doesn't. So it is going to intersect there between 2 and 3 and 3 and 4. Or they both equal negative 3 at those 2 points. Okay, so now we're going to do the same thing, but this time they only want to know for when h of x equals 0. So I'm going to do the same thing on this one because we're not finding intersections. We just want to see when does h of x equal 0. So just like we did before, I'm going to write h of x, and we're going to write all of our values. So at 0, h of x equals negative 1. At 1, it's at 3. At 2, it's at 1. 3 is negative 2, and then 4 is negative 1. Is there a 0 between negative 1 and 3? Yes. Is there a 0 between 3 and 1? No. From 1 to negative 2? Yes. From negative 2 to negative 1? No. And so we would highlight between 0 and 1 and 2 and 3 because that one just had 1. Are there any questions?